Okay, this last week, and this will be the last week of our lectures, we're going to talk about electronics, which is, in a sense, applied electrical theory as well as the advances in technology that we've seen over the last 20 or 30 years. The foundation of electronics is that this is a branch of study of electricity that deals with the behavior and motion of electrons in a vacuum and or in special materials. Electricity, as you know, can travel through a vacuum. And for that reason, early in the development of electronic materials, a vacuum tube became very important. And a vacuum tube is a glass tube that contains electrodes that are sealed in a vacuum. And these are various examples of vacuum tubes. The cathode is the negative electrode in a vacuum tube. The anode is the positive electrode in a vacuum tube. And electrons enter the vacuum tube through the cathode and leave through the anode. And there's generally a gap between these two electrodes. This is a diagram of a vacuum tube. And in this situation, it actually produces a ray called a cathode ray. And these are particles that are emitted from the cathode of a vacuum tube that is in the tube. And the particles that are emitted are electrons. And so the cathode emits these electrons and the anode collects them at the other end. A cathode ray tube is a stream of electrons, also called cathode rays, that would miss the anode and strike the end of the glass tube. The end of the tube is then coated with phosphorescent material called phosphor and can be seen by somebody on the outside. And so what you see here is the cathode is here. It emits electrons, and this electron beam comes through here, and then it's deflected by these coils one way or the other depending on what's going on, and eventually strikes this phosphor fluorescent screen which people on the outside can see. A TV picture tube, at least early TV picture tubes, I'm not saying the TV picture tubes that we have now, were modified cathode ray tubes. And this is what they look like. You have the cathode back here firing the electrons toward the screen. They are changed by whatever goes on in here, and an image is projected here. An X-ray tube is a cathode ray tube that has been modified to produce X-rays as opposed to electrons. And this is an example of an X-ray tube. And the X-rays are produced here and then scatter out in this direction. And the person out here is where you're getting X-rayed. This is called a device that produces thermionic emissions. This is a tube that produces thermionic emissions. What are thermionic emissions? Thermionic emissions occur when current flows through a vacuum tube from a filament of an incandescent bulb and produces a positive electrode. So here you have the electrons traveling here, and they emit these electrons, which are then collected by the anode on this side, but this becomes positively charged because it emits these electrons. The current flows freely from the filament, which is here, to the plate, which is here, but not in the reverse direction, and that's extremely important. The current flows from this direction to here and never in the other direction. And this one-way flow is extremely important in terms of controlling the flow of electricity. Here's another example of the same thing. This is called a diode because it has two filaments. There's a filament here and a plate here. The filament heats up and produces electrons that are then collected by the plate. It is enveloped by a glass envelope, and the inside is evacuated. And this because it has two ends, it's called a diode, or two electrodes, it's called a diode. This allows for the conversion of alternating current, which comes into the filament and changes it into direct current, because the electrons pass directly without a change of direction. Again, remember that I said that this was a one-way flow, therefore any current that's produced is a one-way current and therefore a direct current. The conversion is then associated to periods of flow and no flow. And you can control other devices by having it flow or not flow, depending on whether you turn this on or off. Now this is a triode. A triode has three ports or three electrodes. So like the diode, it has the plate and the coil. The electrons are produced here and flow in this direction toward the plate. But in between is a grid, and this grid acts to control the flow of electrons from the filament to the plate. So the charge, you can control the flow by changing the charge in the grid. So the charge on the grid functions as either to stop flow or to allow flow to go through. If you negatively charge the grid, then the electrons cannot pass through the grid. They will remain on the downside in this picture toward the cathode and not pass through. But if it's neutral, then the electrons pass through the grid to the plate. This acts as a gate to control electron flow from one side to the other. The flow of electrons can vary by varying the charge either in the filament that produces the thermionic emission or in the grid that controls or acts as a gate. And the gate does not have to be either shut, closed, or open. It can be in between, slowing or allowing the electrons to pass. So triodes can allow a human voice to be transmitted and received over radio for long distances, because they can change or vary based on the grid and the electrons that are passed through the grid. The invention of diodes and triodes is what made modern electronics possible. So these early vacuum tubes and the subsequent control that they gave allowed for subsequent development of early electronics. Now this is a semiconductor, and these have taken the place of the vacuum tubes. A semiconductor is a material that neither is a good conductor nor a good insulator of electricity. It's commonly made of a semimetal, such as silicon or germanium. Semiconductors have an intermediate number of valence electrons, which stay with the atom but have enough holes to allow the transfer of electrons. And so that's why they can conduct electricity, but they do not conduct electricity like a good conductor. Now, doping is the process of placing one element with another element to facilitate the transfer of electrons. So on the right here, you have an atom that has an extra electron, so it does not necessarily allow for the passage of electrons very easily. On the left, you have an atom which is missing electrons and allows for the easy passage of electrons. And So a semiconductor that's made of atoms that have a hole is called a p-type semiconductor, and a semiconductor that has an extra electron is called an n-type semiconductor. An n-type semiconductor is when the material is doped with extra electrons and extra negatives, which decreases the flow of electrons. A p-type semiconductor is when you dope with material that has holes that leaves it positive and will facilitate the flow of electrons. So here's an example of a semiconductor diode that's constructed in such a way that you have a p-type on one side, and it's on the anode side, and an n-type on the other side, which is on the cathode side, and in between you have a region of depletion. So a semiconductor diode is the bonding of an n-type and a p-type semiconductor that allows for the one-way flow at the p-n junction. So at the p-n junction, the flow is always going to be from N to P, from cathode to N to P to anode, and it's always going to be in that direction, and the doping facilitates that one-way conduction. And this is essentially mimicking what happens in a vacuum tube diode. You can have NPN triodes, or you can have PNP triodes. So semiconductor triodes are semiconductor devices that function like a triode. So your gate is either going to be positive or it's going to be negative. A transistor, the term transistor, is just another name for a semiconductor triode, and it gets the word transistor from the combination of the two words transfer resistor. Now this diagram shows the impact of a NPN triode, or an NPN semiconductor. So a junction transistor is a small plastic or ceramic transistor, and the field effect transistor is a common device that's found in modern machinery that's part of computer chips, and this is shown on the right here. On the left is your junction transistor. You have the N, which collects on the cathode side, the P in the middle, which acts as a gate and can be varied based on how much electricity is traveling through I subscript B in the base, and then an N on the other side, which transfers to the anode collector, or emitter, excuse me. So solid-state devices are any devices that have semiconductors. Solid-state devices are devices that have this construction instead of vacuum tubes. A photovoltaic cell is a device that uses a p-type semiconductor coated with a thin n-type material, and it converts light energy into electricity. So here is a diagram, and I think there's a diagram like this in your book, but you have light coming in from above. It strikes the electrode on the top, which is negatively charged. There's a film to reflect this, and then you have an N-type semiconductor, which is then under it is a P-type semiconductor, which makes the flow of electricity down toward the bottom of the slide as opposed to being in both directions. And then it's collected by the electrode at the bottom, and then the flow of electricity goes into the load, which is anything in your house that runs on electricity. So the reason you have NP set up this way is to make sure the flow of electricity is down from the sun down as opposed to possibly going up. And it directs the electrical effect of the sunlight into the house and collects the electrons and then runs them through your house so that you can use the electricity. So when light strikes the junction of these layers, it knocks the electrons across the junction into the P area that collects them and then sends them into the home. And this is the photovoltaic effect. Light emitting diodes are semiconductors that emit light when electrical current is passed through them. You might know these as LED emitters that are in calculators and various other instruments. And this is just an example of a light emitting diode. You have the cathode, the electricity goes through the cathode, passes through the light emitting diode and then to the anode, and light is emitted as it passes through. A semiconducting laser is a laser that when current is passed through the junction between the P and the N, it generates a crimson light. And this is an example of a semiconductor laser. When current is passed between the P and N, it emits a crimson light that is generated and travels out to the right or to the left, depending on which way the laser is pointed. Integrated circuits are simply devices that consist of a single semiconducting material, but they contain entire electrical circuits. And their use is the fact that they're very small and very lightweight. So a wafer is coated with alternating materials, and these materials are frequently light sensitive and allow for pictures to be taken of the circuit that's going to be made. And then this raw material is then converted into the circuit that the picture is taken of. So here's how small things can get. The semiconductors can be so small and very lightweight and contain a huge number of electrical circuits. So integrated circuits are cheaper to manufacture, more reliable, and extremely small and lightweight. And so these integrated circuits inside particularly small machines like calculators and cell phones, etc., have replaced any other type circuitry.